Good morning, everyone, and welcome to the guest lecture on anomaly detection in IoT acquired environmental sensor data. The guest lecture will be delivered by Mr. Ashwath Kumar, who is a data scientist currently in Dublin, Ireland. I'll begin with a short introduction about Mr. Ashwath. He has a master's degree in computer science, especially in data science from Trinity College, Dublin. He's currently working as a data scientist at SSE Airtricity, based in Dublin, Ireland. His day to day responsibilities is to work on development and maintenance of algorithms and also to develop dashboards as per the internal business requirements. He has over 2.5 years of relevant experience and he's a specialist in understanding, collecting, and analyzing data. He has built predictive, both classification and regression models, and developed dashboards during his work at the following industries. The first one is the Center for Applied Data Analytics Research, based in University College Dublin, Ireland. The second one is Teresio Limited, which is a fintech startup based in Dublin, Ireland. And the third one is Octavian.ai, which is a non-profit AI research company. So we are indeed very lucky to have Mr. Ashwath with us, who also happens to be one of the alumni of Dr. Diva Patil School of Engineering. So without any further ado, I'll hand it over to you.
Thank you, Pooja, and thanks to Monica ma'am. Thanks to everyone for inviting me. Very happy to discuss the topic of anomaly detection, and this was all related to my research work that I did for one of the startup. No, it's not mentioned in the list that Pooja gave. So it's a work that I did for one of the startup companies here in Dublin, and so the company name was Ambisense. So yeah, and this was during my college days. So let me share my screen, and then we can just start. Can you all see my screen?
Yes, it's visible.
Yes, sir.
Okay. Okay, great. Thank you, ma'am. Okay, so I'll just go through the research work, but I will also give you some background information, like why this project, why company was interested in solving this problem. Because in data science, we always want to know, like what is the business need, and I think you'll all be very happy to know about that, and then because that sets our context on why we were solving this problem, and what were the challenges that we came upon during this work. So anomaly detection simply means anomaly means deviation from the normal behavior. So for example, uh, if suddenly now this cannot just a simple example. If we have a sensor, no, this is all related to sensor data. So if we have a sensor whose expected output is, like, let's say between 0 to 20, and suddenly you discover the value coming from the sensor is around 40 or 60, or maybe like minus or something like that. So what you're saying here is it's deviating from the normal expected behavior. So we'll just classify that as an outlier, or maybe you can call it as an anomaly. So yeah, so that's the definition about anomaly. And an anomaly detection is basically set of all algorithms which we will use to detect these kind of to detect anomalies. I'll first give some background and the company name and what was their product. So the company name is Ambisense. It's a startup in Dublin. You can look on the website because they will have more information about their product. So they developed a product called as Gas Flux, which is the world's first continuous gas and flow monitoring device. and this was so they developed this particular device for ground gas applications. So when I say ground gas, it means if you see on the right hand side, so gas flux is the product that they have developed on the left hand side that you see, and landfill monitoring is the application for that particular product. So what happens is in UK, in Ireland, in most of the EU countries, so like you'll have a landfill site. Landfill site is where you go and dump your waste, like vegetative waste or plastics. So all these wastes will have some place where they will go and they'll be dumped into like a ground. So and it's like a huge space they have. So every and there are companies who manage these landfill sites, right? So now when we have so like every day our waste goes to landfill sites, and what they do is they keep on accumulating all these wastes at a single place, like around the country. Like for example, let's consider UK. And what happens over the time is all these vegetative waste will start reacting, and they will start the decomposition of that particular matter will start. And once it happens, like we will see many gases being released in the atmosphere, like methane, carbon dioxide. And like there will be various gases that will be released in the atmosphere. Now, whoever is managing, like a company or a government, whoever is managing that landfill site will need to, like, will want to know what kind of gases we are releasing. Is it, and what is the measure of that particular gas in that atmosphere. So now for that, now like this is not like we cannot have a person sitting in those landfill sites, definitely, right? To keep on giving us the readings. Okay, the level of methane is this, the level of carbon dioxide is this. So we cannot do that. So, and these are like very big sites. So even like you can think of like a mountain of all the um, waste of amount and the size is like of a mountain. So it's always difficult, and so it's better that we have like a device, and that device is gas flux, so which this company was providing service for. So that's the background, and so I'll just go through more definitions now. uh, Here, like this is the most like you can say a slide where I have put on more information, but after this I guarantee there will be like no not this much of text after these slides. So okay, what is ground gas? Ground gas is uh, basically the gas, like it refers to gases which are released into the atmosphere, like for example carbon dioxide, methane, and these and now why we say ground gas, because these gases are released from the landfill sites by the breakdown of vegetative matter. And as I've already mentioned, so these gases might include methane, carbon dioxide, nitrogen, and you see here volatile organic compounds. So we call it as VOC. Now what happens is over the time, like since these are like very big places, so over the time when these gases are being generated like in the ground, so they can start migrating through the soil itself, and they can leak into the atmosphere at various places near the landfill site. Now imagine you have a landfill site. So as per UK's regulation, like there are various rules around if a company has a landfill site. So they have um, so there are regulations around it. For example, you know you need to like the places which are there around, like just say 1 kilometer, within 1 kilometer range of the landfill site. So you will always the company will always want to know what is the level of methane, what is the level of carbon dioxide released in the atmosphere, because all these gases are released in the atmosphere, and people are living around these areas. So there's now what might happen is, like since these gases are since these gases get released into the atmosphere, so they can accumulate at one place. And since these gases are like explosive. Like for example, just take an example of methane. Carbon dioxide, it's toxic. You might have breathing difficulties. So for any company who is managing landfill site, it is important for them that they know what is the level of methane, what is the level of, like, what is the real time value of methane, carbon dioxide, oxygen level around those sites. And like, I don't know what they have to do, but I'm sure that they will have to report it to the agencies, like government agencies around it, around that area, because they want to make sure that there is no problem in the end. So yeah, so now that is the need of a company which is managing all these waste, like landfill sites. And for them, it is important that they get the correct readings. And for that, they need a device. And that's why they have to go to this company, which will go and install these devices in those sites. And then they will get the readings so that they can take appropriate actions whenever needed. If there are like very high level of methane being released in the atmosphere, so they can take some actions. So I'll just give an example, like what happens if they don't do that. So this is like a newspaper cut. So if you see, there was an explosion which took place near like near a landfill site in USA. And why this happened? Because gas leaked into the atmosphere through soil. And since methane is explosive, so over the time it accumulates at one place, and then if you have anything burning, then it just got exploded. So that's the example. And due to all these cases where we didn't had strict rules previously. So if you see, this cut is, I think, around 1969, right? Now there are cases around, like there is a case in UK which happened around 1980s. But yeah, due to all those incidents, there have been like strict rules have come in. Whoever is managing those landfill sites. So that's why these companies need to make sure that they are reporting the correct numbers to the government or the concerned agency. So I'll just okay. Now, what is the okay? So you've got the background why we are doing this project, and the device that company has developed. And now here, what we want to report is basically whenever we'll have high values of methane or carbon dioxide, uh, if we observe that using the data, or if there is falling oxygen level or battery level problems, like because all these devices operate on solar powered batteries. Now imagine, like, all those sites, and in UK you might not have that much of solar every day. So what might happen is these battery levels might go down, due to which, if battery level is low, then the reporting of by other sensors will become faulty, because there is no power in the system. So you would always want to know, like, flag those cases wherever you have high level of methane or high level of carbon dioxide, or falling battery level readings. So so that is the key concern for any of the company here, I mean the client. So the client would like to know when, like, if the methane level is increasing or not, if oxygen level is decreasing or not. So they're interested in that one. And how they will know that? It's just using the data that gas flux will produce. So this device will produce data, because it has multiple sensors, and it will produce data, and that data will go to both. It will go to Ambisense, and it will go to the company which is managing this site. Now they might have their own analysts who will work on that data and who will take actions. But for us, for Ambisense, it was important. Like, now they have already developed a patent pending device, right? Now always a company would like to innovate, and they were interested in, like, finding, okay, can we apply machine learning to find changes, or this data deviation that I'm talking about, like the anomaly. So whenever there is a change in behavior of the data, can we find that, can we flag those cases? So that's why they wanted to add one more service to their like to their offering. So they already had a device, but they wanted to make like develop a machine learning approach uh, for identifying data deviation. Okay, so research goal for me was um, just develop a solution using machine learning, and we should be able to detect anomalies. Here when I say anomalies, it means data deviation, right? And address the key concerns. Key concerns are this one, like just flag them if you have these cases like CH4 rising, CO2 rising, or O2 decreasing, or battery level going down. So just flag them. So yeah, so yeah, if you have any questions, then you can just like interrupt me in between, and then I can, or do you want to me to just continue?
Yes, class. If you have any questions so far,
Because this will become like it will keep on adding, so it's better that I take questions in between if anyone has any
yes,
questions.
yes, 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 class. Any questions so far? Okay, sir. You please go ahead.
Okay, okay, thank you. So um, okay, so what are the types of anomalies available, like if you want to classify? So we have, so I'll just show the data and then talk about the anomaly type. So if you see here, right, so the now this is the actual data coming from a site. So that gas flux device which I've showed you is producing data over the time. So if you see, this data is from 2016 to 2017. So this is like around um, this is around like 1.5 years of data, more than 1.5 years. Now we had this much amount of data. Now if you see like all these big spikes, right? So that's called a spike, right? It's just so that will be spike type of anomaly here. And stuck at will be basically, if you see B, right? So B is like a constant level. So you can say that now this is a change in the behavior of the data. If you see from A to B, right? So the value of methane, so red is basically methane, if you can see that. So red is methane, blue is carbon dioxide, then dark green is oxygen, and the constant line that you see between 5 to 10 here on the left hand side is basically the level of battery level readings. So now battery level will be like the operating range is between 5.6 to 6.5, something like that, within 1 unit of range. So that is remaining kind of constant. But if you see the level of methane, level of carbon dioxide, it's increasing and decreasing. Now we have a direct correlation between, now this is domain knowledge. So if methane increases, if the amount of methane increases in that particular site, then oxygen will decrease and carbon dioxide will also increase. So it's like that. And if the methane goes down, then carbon dioxide should also go down, and yeah, accordingly. So that's the correlation between different sensors. So B will be stuck at. So it's just what happened is the behavior of the system up to A was something different, and then the behavior of the system changed from at level B, and level C again system behavior is changing. Then again at level D, system behavior has changed from level C to level D. Now would you call it as anomaly? That's a big question. Yeah, for even for ambitions and also for the company that is using this data. So and I'll talk about more in detail, like so what are the types of anomalies here. So that's the definition of anomalies, right? So spike, we have stuck at where the system behavior changes, and we have a new normal. Like in COVID we say new normal. So for this one, level B will be new normal, level D again new normal, level C is a transition from between two states. So you would always want to identify these transitions and flag them. And So here, this is an advanced level of anomaly. So let's say you had this, like we have methane sensor, right? So now people, now this company is dumping waste into that particular landfill site. Now what might happen is over the time, there will be reaction in the site. Then the level of methane will increase, right? So when the level of methane increases, so the first day, if you see day n means the first day, just take an example. So I did a line plot. Now just I'm just showing an example of advanced anomaly here. So you saw that over the day, over one day, the level of methane increased over the mid of the day and then decreased. No, you don't want to generate an alert just on first day, right? Because you would want to observe the system, and then maybe on the second day, or maybe on the third day, or maybe on the fourth day, you would want to generate an alert saying, okay, now the level of methane has changed, or the system has entered into a new norm. So it can take a while. So, yeah, so that's the data, and you have seen level A, level B, level C, and level D. So these are like the behavior of the system is changing. Now, what do we care about? So we care about if the methane level is increasing, if the carbon dioxide level is increasing, report it. If oxygen level is going down, or if there is any problem with the battery level, right? Because battery is powering the whole system, gas flux system. So you would want to make sure that the battery is working fine, right? Or else every other sensor will become faulty just due to power. Now what happens is their engineers visit visit, like you can say, every week to change to check the system, right? That happens over the time. Like now it's not possible for them to visit like every week, so I think it might happen in a month, or maybe in, like bi-weekly, or maybe it's tri-weekly, so something like that. So but they were like they will never change the system just for example, if this system that we are developing, if we see change in the data behavior, and that is caused by hardware fault, if that happens, now we can inform, now that algorithm will inform them, okay, it will flag it. But will they visit the site on that particular day? That's a question. Maybe not. They will observe that behavior, and because it's a cost to them, right? So it's a cost for ambitions to have a visit to the site again and again, because those sites are like very huge, and you just want to minimize your visits to those kind of places, because you have all these like harmful gases in the atmosphere. So questions? Okay, I'll just move on. So okay, so I had this data, right? So you saw this data. Now this is only coming from one site. So I had data for two sites. And what I want to do is I want to report data deviation based on hardware fault, right? And the second type is based on the change in the environment. So what happened is, if you see level B, right, and level D. So in level B, you have some behavior of the environment, like the environment is different in level B. And from level B to level D, the environment has changed because there was no much production of methane, right, in that particular landfill site, or maybe in that particular location. So the level of methane went down. Now this is not hardware fault here. This is just the system's behavior has changed, because methane is still in the operating range of the sensor. Because if we have that sensor saying that sensor's operating range is value is 0 to 100, right? This level of methane is still under that, but you see the values are dropping. Now maybe the algorithm will just say, like, if you use basic algorithms, so algorithms, if you want to know data deviation, so what it will do is it will see, okay, the level of B, the level of methane in case of state B was different, and between B and D the state of data, like the state is different and the data has changed, so it might flag it. Or right, so this is more caused by the environment change and not by hardware. So that's what I wanted to say, and it's better and it is important for us to flag it. What did I do? So I thought like, okay, now this is time series data, right? If you see here, uh, like you see the timestamps on the bottom, we say time frame from 2016 to 2017. So I did this plot on Plotly. You might have used this package. So it's like they have. So I had a premium version of that, but they also have an open source version, so you can have plots. You can develop plots directly in Python. So you don't need to um, like they have front end, but what I did is I was able to use this package directly in Python and create this particular graph. And why I did this, because it gives me 1 year view, right? It gives like I can see the data of 1 year on one page, and then I can analyze or do some initial investigation, like why the values have changed, should we flag it or not. So all these things. So what I did is like I wanted to know um, like it's better that we speak to various researchers who are out there and who are into anomaly detection. So I spoke with these people like from TCS, from Apple iCloud, and Crochet. So these are all the people who are actually working in anomaly detection. I so I spoke with them on LinkedIn. So I connected with them on LinkedIn, and then just spoke to them like what what should be my approach in solving this problem, right? And because I was also reading some research papers on how to solve this problem, and then I thought it's better I speak with researchers, and then take a decision like how should I go ahead with this problem. So Rob recommended me that now we have algorithms like naive Bayes, we have GMM, we have hidden Markov model, and then we have some complex models like autoencoder. It's basically a neural network. So now HMM, right? So this hidden Markov model has the ability to capture autocorrelation. Now, in a time series data, you will want to capture autocorrelation. So these were the recommendations that I got. But uh, the main uh, takeaway from all these conversations was that just apply the technique in increasing order of complexity. So what it means is try the basic technique first. Try a simple technique like naive Bayes, and increase the complexity of the algorithm and see how you're like are you able to identify anomalies or not. So that should be the approach. So take a simple approach, and then in the end try some complex approaches. So what I did, I first prepared the data set. So I can show the data set in a moment, and then I thought, and then we have to build the models, and then we have to evaluate the models. So this is the data set. Now it didn't had only these sensors, but it had like many sensors. But the main sensors are here, like CH4, CO2, O2, then pressure sensors and battery level. And now I also have the expected range, like operating range of these sensors. Now, if I just want to find out hardware fault, then what I can do is I can just apply simple rules, like saying, okay, make sure that CH4 is between 0 to 100. Make sure that um, oxygen is between 0 to 22, like in percentage volume. So I can apply simple rules and I can find out the data deviation, like because normally the data will behave like methane behaving like 18 20, oxygen behaving like 18 20 again. So so that will be the normal behavior. If you like I'll just show you the data now, just a minute. So if you see here, sorry, so that's the data. Now this is all available on GitHub, right? So I'll send you the link later. So if you see, we have sense date where we have the date, right, timestamp. Then we have CH4 reading, we have carbon dioxide reading, we have oxygen reading, we have temperature reading, then we have humidity, then we have gauge pressure, and like various things. So that's coming from one side, and the other one is sorry. Okay, now this is the other site where we don't have those many pump pressure or something like that, but we had only sensors like carbon, CH4, CO2, O2. So these are the main sensors, right? CH4, CO2, O2. Then we have barometric pressure, we have battery level, and then we have a label. Now this label, how we arrived at, I'll just talk about that later. So label is basically saying, classifying this particular row as anomalous, normal, not normal, right? So 0 means normal, 1 means not normal. So whenever we have 1, so it means there is a deviation in the data set, in the behavior of the system. So I'll just show you an example here. Uh, so if you see this one, now if you see line number 11380, the level of methane was around 2.7, then increased to 3.7, then 4, 5, 5, then go down. Then again, in the end, you see that it is now decreased to 0.74 here. Now the data behavior changed from this row to that row. Now we would like to flag it because the system behavior has changed. And now this is more related to environment, like this is due to environment change, and we want to flag it so that the the company like Ambisense is aware of it, and then they can do some like more analysis on top of it, and then they can notify the client, okay, you should look at this or you should not look at this. Now this, in this data set, you just have the like, now this is a new site, right? In new site you will have very less, since the waste is less, so level of methane will be less. But this one, if I show you uh, this data set, right? So this site was quite old, and you will see the level of methane like increasing a lot here. So if you see here, so it's 12 now here, 12, 13. Now it increased to around 20, and then 50s. So you'll see like a very strong change in the system here. So now the level of methane is 30, then 33, then 38, 41, 41, 42. So what has happened is the system behavior is changing since the site is very old. So like there will be waste, and the reactions will be much higher, and then the level of methane will keep on increasing. So now we would want to report these kind of incidents wherever we have a surge in methane, but also make sure, also we want to know the like this one, like we would also want to know whether it is in state B, state D. So we would also want to capture um, the states. So that's the data, and so this is the expected behavior of the sensors. Present that. So one of the problem for me was like I had algorithms with me, like basic algorithms, advanced algorithms. Uh, I found out some Python libraries which can do that. But the problem for me was if I use an algorithm and I pass a row, then how will I know that row is anomalous or whether like it is normal or not normal? So that was the main challenge for us. So like in machine learning, if we have a labeled data set, it's fine, then you can evaluate your algorithms. But if you don't have a labeled data set, then it's a problem. Then you have to apply. Now if that data set has 20,000 rows, then like Ambisense would not want to spend time on going through each of the rows and classifying, oh, this is anomalous, this is not anomalous. So they don't have time to do that, right? So they cannot spend their resources on classifying every data set. So one of the challenge before applying algorithms for anomaly detection was to apply some unsupervised learning and find out some mm, like like classify the rows as anomalous and not anomalous, and give it to the company like Ambisense. And then because if we apply some algorithm like unsupervised learning and find out, okay, this is an anomalous data pattern, this is not, this is yes, no. So if we give them this data, then it becomes easy for them, because like let's say, like I used so for labeling the dataset, we used a few algorithms, and then we used company's domain knowledge. So what we did is we applied an algorithm, and we said, okay, this row is 0, this row is 1. 0 means normal, 1 means not normal, 1 means the system behavior has changed. So so we gave this data set to them, and then they had an engineer who worked on this data, and then he helped us to like correctly classify the data set. So that's how we labeled the data set, because if the data set is not labeled, then again, as I said, it will be difficult to validate the algorithms, like these anomaly detection algorithms that we will be applying later. Now, one of the interesting finding that I had was the percentage of anomalies. If there are 100 rows in the dataset, then the percentage of anomalies is just 5. So you have only 5 rows where there are anomalies. So you can imagine, if there are 12,000 rows, then it will be only 0.05% of rows will be anomalous. So that's like, so training data and test data, there's a big gap here. Like we didn't had that much of test data, um, because it's a new company, it's a new startup, so they won't have, and they didn't had, like these two sites were the oldest that they had, and every other sites were like they were like very new, so they didn't have much data. So one of the challenges, when if you have like very less test data, then it becomes a little difficult to apply these algorithms on new sites. Now what I did is I applied, so these were the methods that I applied for anomaly detection. So you'll see, so there is a package in Python called as PYOD. So it's Python outlier detection, and it is a collection of the developers of this package, the authors, right? So what they've done is they have combined all the algorithms that are available for anomaly detection in one single library, because that is very helpful. Or else what I'll have to do is I'll have to apply PCA differently. I'll have to apply, like, let's say isolation forest differently, and then find out, okay, this algorithm is performing better, this is not. So should I go with it? So what has happened is this particular package has all the algorithms, so I can apply everything at once and evaluate quickly. So that's the package I used. And now whatever you see here, like I won't talk about this much, but these are the ways you can evaluate algorithms. So you have one data set, and you have, like, let's say 10 algorithms. So how will you know which algorithm is the best to choose? So for that, there are ways to do that. First is, the metric is important again here, but uh, apart from that, between multiple algorithms, which one is the best? You can use approaches like feature bagging. You can use weighted average between the algorithms. Now you can use maximization. You can use average of maximum, maximum of average, and threshold. So these are just the methods. Like if you have like 10 algorithms or 20 algorithms applied on one data set, and how would you choose one algorithm out of it? So these are the methods that you can use, and you'll be able to identify which algorithm is the best for that particular data set based on a metric. um, and then I also applied, so now these are all uh, simple methods here, and this is the way you will evaluate, like choose which algorithm is the best. Different approaches, you can say, based on a metric. And complex model I applied was autoencoder. I've also like I've described it before. So autoencoder is a simple neural network. What it does is, if you give an input, if you give a row to the network, it will try to produce the same row again. So what happens is, you provide a CSV file as an input, and that has multiple rows. So what will happen is, I'll just go through that data set, because that will be much easier. So let's say I passed this data set to the autoencoder, right? Now you can find autoencoders in TensorFlow. You can now TensorFlow, H2O, Keras, PyTorch. So these are all machine learning framework. Now, every framework will have their own version of autoencoders. Like these are libraries and they will have their own version of autoencoders. So I used H2O because that was open source, and then I was able to use that. So what autoencoder will do is it is able to, now you have to give this time series data, remove the time column from this data set, and provide these values like these ones, right? Provide these values, just not the label, just this one, just the data. If you provide this, so what happens is you have accept time and label. You provided this data set to an autoencoder, and what it will do is it has an like it will try to reproduce the same row. So maybe it will come up with like so this is around this is like uh, 0.11, so maybe it will come up with 0.12. For 0.72 it might come up with 0.60, something like that, right? Because it is learning from all these data patterns, like all the rows, and it will try to produce the same row again. And when it will try to do that, what we have to do is we have to, so this is the input, so that's our input, and output, like let's say output is this one, just for example here. So what we will do is we will, so if you want to identify how the autoencoder is performing, what I will do is I will just take the mean squared, maybe I can take mean squared error or any other metric that you want to, or maybe you can take absolute difference here. So you can take mean squared error between these two values and find out the error. Now let's say if you supplied all this data, and let's say this row is new test data that you got right now from the site. Like you got this row coming from the site. Now what happened is you already had autoencoder trained on the old data set for that particular site. So this is the new test set. So you provided this input to an autoencoder. So it will give you an output, right? So let's say that gave an output equal to this one, for example. Okay. Uh, Provided this row, and it gave you this kind of nearly same output. Now what happens here, what has happened is it has learned the behavior of the system, like all these rows, and you provided new test data, and it produced the same output. So it means that it has learned the behavior of the system, and definitely the error will be low. And based on the error, you can say that this is anomalous or not anomalous, right? So you can identify that. So that's how an autoencoder works, but you can go more in detail. You know, you can do some research there. And so now, like I have applied these algorithms. Now the question is, how will I evaluate between all these algorithms? So I can use ROC curve. ROC curve is a metric that we can use to evaluate the performance of algorithms. I can use confusion matrix, where I will see, okay, originally this particular row was anomalous, but my algorithm is saying it is not anomalous, right? So I predicted, like originally it was one label, and I predicted zero. So it's so my algorithm is not performing right now very well. So it will be basically like I will just calculate true positives, true negatives, false positives, and false negatives, and then I can visualize my performance of the algorithms using confusion matrix. So again, it's a metric. And the other metric that I used was precision um, at Rankin. So this is more coming from information retrieval area. Information retrieval means Google search. You can think of Google search, and in Google, like in information retrieval, you would always want to look at precision and recall. So those are the metrics. But so we are using that metric here, and here our main focus was that we should focus on now if it is a change in the system, right? Now I'll just go through a quick example here, because so let's say let's take this row, right? You provided this input to the algorithm, like this much. Can you all see my screen, just to confirm? Can you see the data, Pooja?
Yes, sir. Yes, sir. We are able to see it, sir.
Okay, thank you. So yeah, so if you provide this row to the algorithm, so it might predict 0 or 1, right? But originally it was 1, right? Originally it says there is a change in the behavior of the system. So originally it is 1. Like we should report it, we should flag it. So that's a change in the system behavior. We should flag it. But your algorithm said it is 0, right? So if it was originally uh, like 1 and you predicted 0, then we will basically say it is false positive, right? And if you predicted it was originally 0, it was originally negative, but you predicted like you predicted positive, you predicted 1 for it, so um, that will be false negative here. So so here we want to focus on, if there is a change in the system, we should flag it. So that was the main ask by the company. So that's why we were more focused on um, like the the false positives here. So so what I want to do is, um, if it is originally 0, then report it as 0. If it is originally 1, then report it as 1. So I'll talk about the business perspective here, which is the next slide. So what business wanted was, we should have low false positives, right? So false positive means originally it was 1, but you predicted 0, like this one. So I'll just go here again. So originally it is 1, right? There is a change in the system behavior, but your algorithm is saying that this row is 0, like there is no change in the system. So you would like to minimize these kind of cases, or these kind of predictions, right? You would always want to have low false positives, and you want to have high true positives. It means that if it is 0, give me 0, right? If it is 1, give me 1. So you would always want to, now basically you will always it is definitely like true positives. You will always want to have as much as true positives as possible, but apart from that, you would also want to look at false positives, and you would like to have a lower value for them. So for example, if it is originally 1, then, and if your algorithm is predicting 0, so you should have low numbers like that. You shouldn't have many numbers. So let's say if this data set contains 100 rows, right? And as I said, 5% anomalies are there. So 5 rows are the cases where it is 1, 5 rows. And out of 5 rows, you said 3 are 0, right? So your false positive count is higher, right? Because in 5 cases, originally it was 1, but your algorithm is saying out of these 5, 3 are 0. So you're predicting wrong. So you would always want to minimize that number. So you would always want to have lower false positives as much as possible, right? So that was the business perspective. And now a question will come to your mind when you're in this when you're in this area, like which metric I should use to evaluate algorithms, right? So like I always think about like bomb detection. So if you're passing through like whenever you pass through airport security, like whenever you're boarding a flight, so like, and there is a check, like back checks, and they look for, if you're carrying any hazardous material or anything like that before boarding into the flight. Now what, in that application, you would always want to capture, like you don't want to leave anyone carrying a hazardous material, right? So in that case, uh, like even if the person, so here, if the person is if the person is carrying hazardous material, then you want to catch them. So here you would more focus on like lowering false positives, right? Like you don't want to have a system, or like a you don't want to develop a like a detection system or a metal detection system where you have let go a person who is carrying like a you know like a like a hazardous material into the flight, right? So in this case, you should more give value to false positives, and you would always want to have zero false positives. Then only your system will be accepted by the airport authorities, or else they won't accept it. So so based on the business applications, you will use the metrics, right? So my aim was to lower the false positives. I'll just quickly close this because it's been like too much here. But like, yes, so as I said, I used unsupervised algorithm to label the dataset. So one of the algorithm is GMM, and this works on density region. So what it does is it will just take the dataset. It will prepare a density region, and if your data points are falling out of this density region, then the probability of that particular row being an outlier will be higher, right? And then you can flag it. And then this input was given to the company, and then the company, based on their knowledge of their systems, they classified, okay, this is anomalous, this is not anomalous. Even if GMM said this is anomalous, maybe the company will say it is not anomalous, right? Because they are the one who are working on the ground, so they will know more about their system. So I used GMM to classify the labels, and the input was given to them. uh, just to end this one, so findings were for me, the main challenge for us was labeling the dataset, because if you don't have a labeled dataset, then your algorithms, whatever algorithms I spoke about in the start, the methods that I showed you, will won't like they don't work. Like they need labeled dataset. And here I found that unsupervised learning was very important. Like just take an example of GMM. It's very interesting algorithm. You should look into that. And if the site is in operation, then the behavior of the system is changing, and it adds more complexity to whatever algorithms they're choosing. And maybe uh, your algorithm should be able to adjust to the new normal of the site or of the landfill site. So that is again a challenge, and maybe here you will need to retrain the algorithms, because the behavior of the site is changing. So you cannot be like take a data set of past 1 year, train the algorithm and leave it, and just predict. So that won't work. So here the idea of retraining comes. So because since the system behavior or the site landfill site's behavior is changing, environment is changing based on the waste, vegetative waste. So that's why you will need to retrain the algorithm, maybe like every month, whenever you have the data set available. So you'll have to do that. And again, for retraining, you need to make sure that you have a labeled data set. So again, that's the challenge there. And solution that I like from my research work, I already had a very good accuracy. Like you can say, my ROC curve, my precision was very good, and the accuracy was around 87%. So it was quite good. But again, it was, as I said, it had little false positives, and it was very difficult in few cases to teach this idea to the to teach these patterns to the algorithm. So it always becomes difficult. So the idea here is that instead of using single algorithms, maybe why not use outlier ensemble. So outlier ensemble is basically a stack of multiple algorithms that can be used. Like what happens is one algorithm is trained, and then that input goes to other algorithms. So that's how it works. And then you can use autoencoders, and you can use both the system, because in autoencoders you don't need a labeled data set, right? But in outlier ensemble you might need a labeled data set. So you can use both the approaches and find out, like build a better detector for to identify data deviations happening in the system. And one more thing that we found was, like, we shouldn't go to a company for labeling the data set, because they're not interested in that. So Now, for my research, it was very important that the data set should be labeled, and then only we'll be able to come to a conclusion there. Or so we need some heuristics or some, like automatic rules. But here again, even we had the rules, right? So, but we will still need some domain expertise here to flag those data deviations, because the data is fine as per the sensor operating range, but the system behavior has changed, and now being us, like I'm not like working in that industry, so for me to look at the data, and if I'm coming from that industry, it is fine, like I will know this is anomalous, this is not. But if you're not coming from there, then you will have to go to the company and ask for input on labeling the dataset. So that is always a challenge. Labeling, it is a big problem, like industry wide. So you should try to minimize, I will say, try to minimize your like meet the company for insights or asking questions, but like they don't want to like sit on classifying every row, this is anomalous, this is anomalous. So they don't I think they don't want to do that. So that was one learning for me. So that's all. I will stop here, and questions are welcome, and yeah, we can take it forward.
Yes, sir. Yes, sir. So, class, do you have any question on this? Yes. Yes, Shreya, please unmute yourself.
Thank you, ma'am. Hello, Ashwath, sir. Priya here.
Yeah, hi. Hi.
Sir, I'm interested in knowing that what made you take this research project topic.
Like, how did I choose this one?
Yeah.
Uh, that's a big question actually. So what happens is, like we had so like this is a startup, right? And so we had few opportunities available, and again, this was like a competition here, but but then like you know you see these opportunities around your college, right? Like in my case, I found this opportunity, and then the company was interested in working with us. Then I thought, okay, uh, it's better, like my thesis, if it is in collaboration with a company, and if I'm working on real world data set, it will be something new if I research on this, because it is like unsolved problems. And yeah, so that's how I came via this like idea, and then I just got onto that. But this was not something automatic, so you can say my ears were open, eyes were open, and then I saw the opportunity, and then I got onto that one.
Okay.
So you should look for startups, and you should find out if they want to solve problems, like by algorithms.
Try to be the problem solver.
Yeah, yeah. So
Okay. Yes, sir. So, next question is will be asked by Kritika. Yes, Kritika.
Yes, actually, I wanted to ask, as per you said, we need to label data first in order to apply algorithm. So
mhm.
I wanted to know the amount of data, means the amount of data you required to label, and where to stop, means the more amount of data, the more accuracy you get. But how should we know that yes, this is the right amount and we are getting the accurate labeling?
See, like it is more on the percentage of train and test, I will say, not on the actual amount of data. Now, it will always be good if we have like as much data as possible. Like let's say, for example, in my case, I had around 12,000 rows, right? So in my case, if I had more data, then it is always better, right? But even in that case, even in 12,000 rows, make sure that everything is labeled, right? Like in my case, it is important that it is labeled. So and then now when you label it, let's say if it is a classification problem, and if you label it as 0 and 1, so you will always want to know what is the split of 1, like what is the total number of rows where the label is 1, and then the ratio of labels, like 1 versus 0, and then you should see this ratio, like how it is. Now it is always good if we have 50-50, right? So if we had data, like let's say, as I said, I had 5% of rows which were anomalous or which were labeled as one, but that percentage is like very low, right? So, and when you, and there is a chance of overfitting, right? Because if you don't give the rows where the label is one, if you don't split it properly, then there is a chance that your algorithm might overfit, and it will change the the algorithm's output. Like, let's say if I had 50 percentage 0, 50 percentage 1, 6,000 rows where it is 1, 6,000 rows where it is 0, the algorithm's output will be different. It will be much more reliable, I will say, as compared to 12,000 rows and just 100 or something like that. So so it is always the percentage of 1 and 0, like the labels, I will say, and not on the total amount.
Okay, sir. Thank you.
Okay, class. Anybody is having question? Any more questions, guys?
I think
Okay,
Kritika has
so
raised her hand.
uh, yes, sir.
I think someone has raised the hand.
Krutika has also asked the question already, sir.
Oh,
Yes,
okay, okay.
KG is there. Who is yes? Sandesh wants to ask. Yes, Sandesh. Yes, Sandesh. Are you there? I think he has put it in chat.
Okay.
Uh, okay, Tejas Bafna, do you have any question? Okay, so he has put this question, Venkatesh Shinde. Sir, after you found out that amount of methane gas or the other gases that are harmful are increasing in a particular area, what does the government agencies do to keep it in control?
No, that is that is the responsibility of the company which is managing the landfill site, right? So what they do is so now now the regulations are very different. In the earlier days, we had let's say there is a site just in front of near my home, within 1 kilometer range. So now the regulations are different. So you cannot have a home near that area. So you'll be away from that site, like let's say 2 kilometers or 3 kilometers at least. So you won't be very near to that site. But in the older days, it was not the case, due to which there were issues with these with these gases being released into the atmosphere. So, and even if the houses are near to a landfill site, so they have some absorbers, so they use, the government and the company will work together, and they will make sure that they are blocking, you don't want to have a crack in the building. Like, let's say if you have a house, you don't want to have a crack there or anywhere else. And because if you have a crack, then there is a chance that the gas might enter, it just enter, you can't see that, right? So it just enters and then it accumulates over the time. So what they do, what these government agencies do, is they make sure that all these houses, if they are there near a landfill site, they make sure that they are well secured, and they are not letting in these gases coming into the houses or anything like that.
Okay, so there is one more question from Sharad Kumar. What if people move out of their house?
Can you elaborate your question? I didn't. What if people move out of their house? Like, if they want to move out of their house, or
Can you
um,
please elaborate, Sharad, in what reference you are asking the question? Okay, sir, there is no next question. How did you get started with AIML?
this was in DY Patil, I will say. When I was we
Yes,
had a
yes.
subject where like
Yes, you
monochrome.
have the
So
subjects in the syllabus. There are so many people from AC here. They might not be knowing because this subject is there in the final year. And whatever terms that sir has explained, all these terms are there in the syllabus in theoretical manner. But sir has actually given you the practical perspective of it. So the students, it is there in final year, and from that only I guess Ashwath has got the path to get into the field, right, Ashwath?
No, I think there are few people, but for me, I see only two or three people in that area, not many. Yeah, so that was my motivation. Like I used to like work on algorithms, and then I used to like algorithms, and then code it in Python. So Python algorithms, and then I found about data. So that's how my journey started,
Yes,
and then I chose to specialize in data science itself.
yes, yes. So, guys, he was your senior. He is from 2016 batch, and he was a very prominent student, very focused, very product oriented. So, being a senior, would you like to ask him any questions? He has done his MS also. So, in that view, do you have any questions? He was very sincere, very obedient, and very regular. He is always used to have 100% attendance. So,
Not
with
every
that
time.
aspect, do you want to ask guys anything related to academics or the student's journey? There is one more question. How frequently you retain the model?
Uh, in my company, like we have a different application, but so we generally do it like it's monthly, right? Generally it is monthly, but in this case, again, whenever we have the data set, now every day, let's say, now you should be like the data is coming for ambitions, the data is coming like every 1 hour, right? Or maybe like every no, it cannot be every 1 second because it is a cost to them. They cannot have a system where the data will come like every 1 second, so they have to have a trade-off. And so they were sending data like in every 1 hour, so in one day you'll have 24 data points. So in 1 month you'll have 24 into 30 data points. So I think it is better to train the algorithms after 1 month.
Okay. I hope the student has got the answer. Yes. Anybody else? Any more questions, guys? Yes. So I guess there is no more questions. So thank you so much, Ashwath, for yes, there is one more question from Dr. Sunil Rathod, our
Yes,
professor. Do you
Sumit sir.
remember Ashwath Rathod, sir?
Yes, yeah, I
Yes,
remember.
yes, sir. Yes, sir. Rathod, sir. Yes, sir, please.
Yes. Thank you, ma'am. Thank you for giving me chance. I would like to ask our respected guest that will you please make this thing clear to the student that how significant is the final year project? Because what I observed nowadays, it's okay that from last 2 3 couple of batches I may say that students are trying to do project on their own. Otherwise, what I saw was that it was a tremendous outsourcing of the project. 80% of the cases practically I saw that there is outsourcing. So I would like you to means throw a light on this so that these students, these budding second year brilliant bright students, beautiful students will try to understand it.
Uh, yes, sir. I'll just talk about that. So even when I was in Diva Patil, so now we could have done a simple projects which involved like web development or something like that. But then we did a project in IoT, right? And then that became my inspiration to pursue something related to IoT and something related to machine learning. Um, so so my bachelor's project actually gave me an inspiration to pursue uh, like a thesis, like a master thesis into that particular subject area, and in the same in domain, like data science. So I personally, um like it is very important for students to choose what type of project they want to pursue. And if there is any challenge, or like let's say if it's a hardware level project, then they should actually go out and get those devices. So our device, when we were in Diva Patil, so we got devices from US. So we went to that level, just to get the devices and make sure that our project goes smooth. So this was very much appreciated by the external, and he was very happy that we went, like we tried to get these devices because these were not available in India. So we actually found out some connections, and we got those devices in time in India, and then we used those devices into project. So they were very much pleased with our efforts, like our self efforts. Like, okay, we used Python to do that. We used some like databases. We used little web development where we were making API calls. So uh, and then we had a hardware also. So like my fourth year project at Diva Patel. So if you take some efforts like by yourself and go out and then do something which is something which is new, then it will be very much appreciated, and then and then you will learn a lot, because when you do something new, right, you don't know anything, right? So then there is a your learning curve will be much better in that case. And I will say, challenge yourself in fourth year. Do
Right.
something which no one has done.
Yes, right, sir. Right, right. So, Rathod sir, do you have any more questions, sir?
No, ma'am, it's okay. He answered in very
Yes,
satisfied way.
yes,
No
yes.
problem. Thank you.
Thank
Okay,
you,
thank
thank you,
you
sir.
so much. Okay, guys, anybody else is having any question? Okay. So thank you so much, Ashwath, for taking out time for us and sharing your valuable data with us. This all we have studied in theory, and you have actually shown the
Please
practical
check the
also.
message box.
Yes, guys, please mute yourself if you do not have any question. So, Ashwath, thank you so much, and we would like to have you for the future events also. He has witnessed so many events of ours, and he was guest and judge for so many events of ours, and he still follows us like a child. He's still the same obedient student. Okay, there is one more question. Sandesh, do you have question now?
Yes, ma'am.
Sandesh?
I want to ask,
Yes, yes,
sir, that from a student of D.Y. Patel and giving a guest lecture in front of your own college, in front of those teachers who have seen your growth,
yes.
how are you feeling right now in guiding us?
I think I should give credit to Monica ma'am here, because I think she's keeping track of like what I'm doing. So give credit to her. So yeah, like I feel good. It's good to help, right? So because even in our time, like I was reaching to seniors and trying to understand, like what is important in the industry. What should I do? Even to get a job, like what should I do? Like should I learn Python? Should I learn C++? Should I learn Java? So I don't know. So I was reaching at that time. So yeah, it is a great feeling, I will say. And I hope you all will be like that. You could guide your juniors when you pass out.
I would advise all the kids right now to be like him, because even after reaching to that height, he's still so down to earth and still like a child. He is always ready to learn. So it's very difficult to be at that place and being down to earth. So that is to be learned from him. So I guess we should stop here. Ashwa sir, I would like to inform you that there is one more event in the line. We have one more event, a cultural event at 2 p.m. So would we like to have you there also? If you have time, if you could give some more time, we would like to have you as a guest and enjoy yourself. So we have the cultural event at 2 o'clock, sir. This is just for your information.
Uh, yeah, but anyway, I have
Okay.
I have a meeting coming up after one
Yes,
hour,
yes,
so
yes.
I will
Yes,
see. Like,
definitely.
if it is possible, definitely I will join.
Definitely, 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 sir. So hope to see you in future also, sir. For further events, we'll like to have you for our meetings. So we should stop the meeting here now, guys. Thank you so much, sir. I thank HOD sir for giving all the support to this guest lecture. I thank all the teachers who joined us to hear their old uh, uh, student delivering lecture right now. I appreciate all the students who joined and listen to Ashwath carefully, and I thank everyone out there. Thank you so much, Ashwath sir. We'll stop here. Have a good
Yeah.
day.
Thank you. Bye. Bye.
So, class, the meeting attendance was shared. I hope you have filled in. Now we'll stop here. I'm stopping the meeting.